Hey CactusCon, my name is Burke, and today we'll be talking about PacketSifter, which is my tool. We'll talk about that, and leveraging TShark for network traffic analysis. So before we jump into it too deep, I'll just give you a brief overview of who I am, and maybe why you should listen to me, right? So my name is Burke, like I mentioned. I am a security consultant and a cybersecurity instructor at a local university in Houston, Texas, which is my next point. So I'm from Houston, Texas, born and raised, lived there my whole life. So I'm a Texans fan, you know, all that fun stuff. I guess my one fun fact or my hobby is that I'm a board game enthusiast. So I'm a huge fan of board games, and I happen to think they're pretty cool. So a wild night for me might be pouring a glass of red wine and enjoying a board game. And yeah, that's my fun time, right? Nice to be here. Thank you for having me, and let's go jump into the agenda. So for today, for this session, it's going to be a sort of half and half sort of PowerPoint presentation, half demo. Just for now, we'll talk about what TShark is for those of you who may not be familiar with what TShark is. We'll actually talk about some of the basics you can use to even begin, even today, starting to look at random pcaps and see what data you can pull back just by testing some simple TShark queries that I give you within this slide deck here. And then we'll talk about PacketSifter, which is the open source tool that I created that leverages TShark, and I'll show you how to use that, of course, within the demo portion. So that is the agenda for today. Hopefully that sounds good, and let's jump right into it. So TShark. So TShark is much like Wireshark, if you're familiar with that, which is a network protocol analyzer, except it exists on the command line. So you don't have this pretty GUI with all your little buttons and bells and whistles that you can click on stuff. All those good things aren't really available, right? We have to use the command line to accomplish what we need to for network protocol analyzing. So TShark is great because it enhances the capabilities that you can do using the command line. So now I can use things like sort, I can use things like unique, sed, awk, and so on. Even, grep, I should have put grep there, but grep can be used as well, which is a great tool to use. So you can use all these relatively known command line options and arguments and tools and pipe that into TShark, or use TShark to pipe that into the other tools. Either way, it's a great opportunity to explore sort of enhanced capabilities you might not get using something like the GUI. So we'll talk about some of that, and I'll show you some queries you can use to begin making an impact today in analyzing network traffic. So you might be thinking, well, why would I need to use TShark if I can just use Wireshark? I don't really see the point. Like I said, it's pretty, it's nice. I have all these, sweet colors on the screen, right? We have green and blue and purple, all that fun stuff. Which, little side note, you can do in TShark as well, get the nice colors. But so you might be thinking, right, like, why do I need to use this when I can just use the GUI? But you might not have that opportunity all the time. Sometimes you might have appliances where they don't have a GUI interface. There's no GUI front end, so you might just have to leverage the command line to do it. Other times the GUI is just not sufficient enough when it has such a large amount of data in there to sort of process, right? So one of the benefits of Wireshark and TShark is the protocol analyzers you can get and you can leverage to sort of dissect some of the data you're seeing. And there's some rules that fire even within TShark and Wireshark to sort of pick out noteworthy activity, something like a duplicate sequence number, sort of off, there's a bunch of different things you can fire on, right? And all that stuff takes processing time. So if I have a gigabyte large pcap and I try to pipe that through Wireshark, if you've never done that, you should try it for fun. But it's a frustrating experience, right? Because you're waiting on Wireshark to do all this aggregation, all this enrichment, and dissect all these protocols, and it takes a while. And each one of your queries you use within Wireshark might take a long time to return as well. And so that is why you might want to use TShark instead, because now I can just run TShark, and without having all this GUI front end, I can get back my data relatively easily. I can sift through that data to make smaller pcaps to make it more digestible for Wireshark as well. So there's a lot of benefit from using a command line interface to use or network protocol analyzer on the command line rather than using it in a GUI. So let's talk about the basics, right? So now we know why we need to use it, right? Because pcaps might be too large. We don't want to sit there and wait for our data to come back. So let's dig into some of the basics that we can use. And so on the screen here, I have listed a very, very basic TShark command, and the sort of associated options are listed out there. So we're going to read in our input, which is the tac-r input.pcap. So that's going to read in our input file. The tac-in is saying, I don't want to perform hostname resolution, which I think by default, your TShark and your Wireshark profile will do this for you. It won't resolve host names, but just to be safe, I always put that in there because you don't want to poke the bear. You don't want to tip off the attacker that you're sort of, investigating them. So you don't want to have DNS queries just beacon out because it's within your pcap and TShark and Wireshark are trying to resolve host names. So to be more subtle about it, you turn off hostname resolution, or you just cut off internet access on the VM you're using to analyze the pcap. There's several different options, but that's a good one that I always put in there. It's always a staple. And then the tac capital Y is going to be your Wireshark filter. Or Wireshark display filter, I should say. So if you ever use Wireshark, you know that you can do great things like, in this example, tcp.deskport equals 80. And one of the benefits of Wireshark is it has all these dissectors, all these parsed fields, if you will, where you can just call out, I want to look at only tcp.deskport, and I want to make sure that it equals 80, which is the HTTP port. So you can leverage that on the command line with TShark. So it's not just Wireshark, you can use this stuff. So I can just feed this into my TShark command and filter out only web traffic or potentially web traffic, right? And then the last part, tac-w is output.pcap. So I'm going to write out my output to a file rather than printing it to my console. And so this is the output of that. So what I did is I just ran the command at the very top there, and I went ahead and ran a head command to just pipe out the output from that pcap. So I ran tshark tac-r output.pcap and piped it to head. So again, like I mentioned, you can use some of these native command line tools to enhance the capabilities on the command line using TShark. So now I read in my pcap and I just want the first 20 lines. And you see we have 20 lines here, and it's all port 80 traffic. So destination port 80 in this instance, which we're going to assume is web traffic. But you can see that this filter, it worked, right? So now we have destination port 80 traffic all contained into one pcap. So pretty nifty, pretty easy to do. With Wireshark, you can do this, yes, but with TShark, if you know what you want to pull out, why load it into a GUI? Why do all this extra work when you can just run this command here, right? So great stuff. It's awesome. And if you ever use Wireshark, you might be familiar with the statistics portion of it. So you might pull down the protocol hierarchy. You might do endpoints, might look at sort of who's the biggest talkers within that pcap. Things like that, of course, are available in TShark as well. So within TShark, there is the tac-q and tac-z option. So these are going to be new options that we haven't seen yet. And so again, we're going to read in our pcap, we're going to turn off hostname resolution, and we're going to do a tac-q, meaning we don't want to see all the output of reading in that pcap. So if I just do a tshark tac-r input.pcap, it'll read every single packet and print it to the console, which we don't want to do that. So to suppress that, let's give it a tac-q for quiet. So we're going to suppress that output and then give it a tac-z. So the tac-z is saying, let's run statistics. And so now I can use all the native Wireshark statistical functions that you might be familiar with just within the command line, right? And so now I run tac-z io, phs, which stands for input output protocol hierarchy. And so on the next slide, you'll see what that looks like. And again, if you've ever used Wireshark and used statistics, you'll be familiar with what the output looks like. One thing I did want to highlight is in this bottom right corner here, if you aren't familiar with what TShark can do on the statistics portion, if you just run tshark-z help, it'll show you all the sort of options you can provide with the statistical portion of it. So highly recommend checking that out and sort of seeing what you can do, because you can do a lot of stuff and it's pretty cool. So this is the output of that command. You see I ran the command, I piped it to head just to show the first 20 lines, and we did protocol hierarchy statistics, PHS, and you see all the various hierarchy or protocols in a hierarchical fashion, right? So it shows you the frames, the bytes, and so we can pick out that we have DNS traffic, we have UDP DNS traffic in here, we have some NTP traffic in here, and so on and so forth. So again, very easy to do. Without doing many clicks, I can just write this command and have the protocol hierarchy outputted to a file that I can reference later, or whatever you want to do with it, right? But it's a cool thing to use. And then my very favorite part of this, part of TShark rather, is the field extraction. So we're going to add a few new commands to what we already learned. So again, we're going to do TShark. We're going to read in our input.pcap. We're going to turn off hostname resolution, and we're going to filter on HTTP traffic. So we're going to rely on the TShark dissector to give us only HTTP traffic, and we're going to give it the tag T, which is going to be set the format of the output. So whatever output is printed to our screen, we want it to be in, you can provide JSON, you can provide fields, for instance, which is what we're using here. So you can give out, or you can request rather from TShark different sorts of output. And in this instance, we're going to look for the fields. So from our output, we only want fields extracted. And the field specifically that we want is the http.user_agent field. And so whenever you supply a field that you want to parse out, you have to give it a tag E every time. So if I had two fields here that I was trying to parse out, I would do tag E http.user_agent space tag E, I don't know, http.host for the host header, right? So you can give it several different field options and make almost like a report that you can just pull out of the data, which again, I don't think you can really do with Wireshark. Could be mistaken, because people do some crazy things with Wireshark, but you don't get that capability that I understand, and it's not as easy to do. If you use TShark, you can do this stuff, right? One thing to call out is the fields that can be extracted are listed in this document here. There's a lot. If you haven't looked at it, I think the HTTP protocol rather has thousands of fields you can pull out. You can pull out the cookies, you can pull out the header, individual headers itself. You can do a lot of crazy stuff. So definitely a good thing to check out. But let's look at the output of this, right? So the output of this command is this. So you see here, I ran the command and I pulled out the http.user_agent field, and we have this output, which is great because now we're only seeing what we want, which is that user agent, right? If I see suspicious user agents in my web traffic or this Pcapp in general, then I know something might be fishy. But one thing I wanted to highlight is you see there's gaps in here. There's blank spaces in between these results. That is because I'm only pulling out HTTP traffic. Not all HTTP traffic has user agents, right? If we think about how web traffic works, the client issues a request and the client typically includes the user agent field. It's optional, but typically it'll use the user agent field in the request. The server responds to that client and it doesn't include a user agent field. It might have a sort of server identifier, right? A banner, if you will, that says, hey, I'm an Apache web server, or I'm an IIS web server, but it doesn't have a user agent field. So all of these we can assume are associated web traffic without user agents. So we don't really care about that, right? I don't want to see a bunch of blank spaces in my results. So what we can do is we can enhance this by saying, I only want to filter for values that contain the user agent field. So I don't care about the initial SYN, three-way handshake part of it. I don't care about responses from servers. I only want to see when a client initiates a request and includes a user agent. So by running this, and we run the similar parameters we ran on the last slide, you see we don't have any spaces anymore. So we only get back the data we care about, which is, again, the user agent field. So now that we have that, let's run some native Linux commands and enrich that data a little bit. So I can run my command that I just showed previously, and let's pipe that into sort. So what that's going to do is let's just group the like values together. Let's unique them and get a count of that. So I want to aggregate those results and give me a unique count. So moving on, right? We have the sort, the second sort that we use, and we're going to do a number sort. So we're going to sort from the lowest to the greatest, least to greatest, I guess you could say. And that is what the output is here. So running this, I aggregate the user agents that are contained within this pcap, and I want to look at the lowest common user agent in the pcap. So give me the least common. And so at the very top, you see we have a 1 value, which is the number of curl requests 7.69.1 contained within the pcap, and so on. So just running this quick command, you can tell that this value here, this 129 count for the Pixel C Android user agent, is pretty common in this pcap. I might not really care about that if it's a common user agent. You know, if I see Chrome or might see, Edge or whatever it might be, I don't really care about that. But if I see curl happening in my pcap that I'm not familiar with, if I see, the Python request or Python web server in the host header, for instance, if I'm doing other sorts of aggregation on different values, then it might be sort of suspicious to me, right? So not only does this work for something like the user agent, but you can do this on other values, host names, you can do it on website names, you can do it on IP addresses, you can do all sorts of aggregation and really hunt through the pcap you're looking at without using and relying on Wireshark to do that legwork for you. So it's a great opportunity, and TShark is awesome. And if you've never seen this stuff before, I highly recommend using it because, again, I'm a TShark fanboy. I love it. I use it so much that I forgot how to do some stuff in Wireshark even because I rely on TShark so much, which is, that's fine, right? You look cool when you're hacking on the command line, right? Instead of using the GUI. And that's the dream, right? So I highly recommend looking into TShark if you haven't. But yeah, so let's pivot into PacketSifter. So I recognized that there was a problem, right? And PacketSifter was a solution to that problem. So the problem is if we use Wireshark a lot and we have large pcaps, it takes a while to load this data, and we become sad analysts, right? Which we don't want to become sad little analysts, right? I know it's cute over here, but we don't want to be like that. We want to be happy and ready to do our job and super efficient in what we do. And so I found that, TShark is great, but things like using the statistics portion to pull out protocol hierarchy and endpoint biggest talkers and things of that nature, it's repetitive to continuously do that on the command line, write that command out, get the data, and then sort of read it in a human readable format, right? So what PacketSifter does is instead of having to type all those things out individually, what PacketSifter does is it receives the input, which is this large pcap on the left here. PacketSifter, the tool, which is a script that'll run. It's a bash script, so it's very portable. And what it'll do is it'll pull out various different data points for you automatically, so you don't have to do it yourself. And then there's also enrichment capabilities, which we'll talk about here as well. So just from the top, excuse me, it pulls out text files. So it'll create your protocol hierarchy, it'll create your HTTP statistics, TCP IP statistics. It runs a bunch of statistical values, or requests rather, against that pcap and prints it all for you in one nice little place, so that you don't have to run those individual commands yourself. Time saver, love doing that. That's one of the first places that I look at whenever I get a new pcap that I'm investigating. So the second portion is it'll carve out smaller pcaps. So what it'll do is it'll take one large pcap and then carve out several different ones depending on the protocol. So automatically it'll pull out HTTP traffic, SMB traffic, FTP traffic, and DNS traffic into 4 different pcaps for you. So if I want to only look at DNS traffic, I already have a pcap that is contained or that only contains rather DNS traffic, which makes it easier for me to work with as an analyst. The next thing it'll do is it'll carve out all the objects, all the web traffic objects and the SMB objects automatically and throw it into a tarball for you. So if I'm investigating, some sort of potential web traffic compromise where I see a user downloaded something suspicious, this will pull it out for you. Of course, the caveat to that is be safe when you're unzipping it and clicking on things. You don't want to run things that you shouldn't run, right? But that's why it's zipped up, just because there's a little bit of extra protection there that you have to do the work to unzip it. But it does it for you, so you don't have to do that yourself. And lastly, it has capabilities with VirusTotal and AbuseIPDB. So what you'll do and what I'll show you in the demo is you feed it your API keys for VirusTotal and AbuseIPDB. And once it gets those API keys, what it'll do is it'll take the output from the HTTP and SMB objects, and it'll do an MD5 lookup on all the objects and compare it with the VirusTotal results. So what that does is it'll create a new text file for you. It'll show you the results of those findings. So it'll say, this object was found to be malicious. This object, was found to be benign. And it really helps the analyst just run this pcap through PacketSifter, and then I already have output that I know might be potential indicator of compromise, right? If VirusTotal says 45 out of 67 vendors found this file to be malicious, then I know that might be something noteworthy to look at. It gives you the file name, so you can go back into the Pcapp, find the file, and sort of see the beginning parts of that conversation. So you can really dive in to see why this user downloaded what they did, right? So it does that for web traffic and SMB traffic, which is great. And lastly, the AbuseIPDB integration, what it'll do is it'll look up the DNS A records within the Pcapp, and it'll look up the IP addresses and see, was this A record was this IP address rather associated with known malicious activity? And so you'll get another report that says the confidence level out of 100 is 50 for this IP address. So this IP address within the last 30 days has a abuse score, if you will, of 50 out of 100. So it might be something noteworthy to look at. If I'm an American, business, an American association that doesn't do business with something like maybe Russia or China or whatever it might be, if I see that I have web traffic or DNS traffic rather, beginning out and it's registered to an IP address in China or Russia, then that might be something noteworthy for me to look at as an analyst. So it parses out a bunch of data for you so that it'll ease the analysis for an analyst. So I don't have to go into this pcap, this potentially large pcap, and extract objects manually, look up IP addresses manually, and carve out data manually. It does all that for you. And again, on the command line with Bash, so it's super portable. And we'll talk about that in the demo, right? So I'll show you how this tool works, and we'll do a small little investigation so you can see how this tool works in action. So with that, I will see you in the demo portion. Okay, so now let's jump into the demo portion of this presentation. What you're looking at here is the GitHub repository for PacketSifter. You can find it at github.com/PacketSifter/PacketSifter tool. The main thing I want to highlight here is the requirements to run PacketSifter. At the very least, what you will need is TShark. Of course, we've been talking about it for the past 20 minutes or so. I love TShark. I built this tool off of TShark, so you will need that. But if you want to run the integrations that I built with VirusTotal and AbuseIPDB, you will need JQ to format the JSON output, and you will need curl to make the actual API calls. So make sure you have both of those and TShark as well. So once you download the tool, there are 3 things you will need to extract from it. You will need the tool itself, PacketSifter.sh. You will need the VirusTotal initial.sh, which is the initialization script for VirusTotal. And you will also need AbuseIPDB initialization script. So these 3 scripts you will need to run the tool. So let's go ahead and jump into the command line portion. Okay, so now we are on the command line. Let's close this out just so we don't see this in the background here to distract us or anything. So I downloaded the tool. I mentioned we needed those 3 scripts, and I have those 3 scripts listed here with run capabilities, so we can go ahead and execute these. So I'm not going to show you my VirusTotal API key because those are hard to come by. It takes a little bit more work than AbuseIPDB to get an API key. So I will not show you that, but I will show you the initialization script with AbuseIPDB. So let's go ahead and run this. And it needs to run in the same directory as PacketSifter itself, or it will not work. So all it's asking for here is the 80-character API key from AbuseIPDB, which you can get freely just by going to the website, logging in, creating an account, and requesting an API key. We give them the API key, and now you should ideally get a google.com response back. This indicates that the curl request was successful and the tool is set up with your AbuseIPDB API key. If you do not get this, then there could be a whole slew of issues potentially, right? You had to kind of test to see what went wrong. Maybe your internet connection isn't, up and running. You might have a proxy that isn't configured correctly. You might not have curl installed. You might not have JQ installed. It all just depends. So you just have to do some troubleshooting. But as long as you give it an API key that's valid and you have a valid internet connection out, you should be, good to go. So here we are good to go. And now, again, I'm not going to show you the VirusTotal one. And just on the side there, I know I just exposed my AbuseIPDB API key, but like I mentioned, super easy to come by. So I will detonate that API key after this recording so nobody can leverage that API key in the spirit of good OPSEC, right? So now let's change into my output folder. This is just a nice place to put all the output data from the tool itself. So I'm going to run PacketSifter, and I'm going to run it with the TAC-H argument first, just so we can see the help file that prints out. So it'll highlight the various options that you can use with PacketSifter. The required option TAC-I is for the input file. You will need that to pass in your pcap argument. So you will always need that. And if you have the integration set up for AbuseIPDB and VirusTotal, you can use the TAC-A for the AbuseIPDB integration or TAC-V for VirusTotal. And also, if you want to resolve host names in the pcap itself, again, you might not want to do that because you don't want to necessarily tip off the attacker that you're investigating them. If you did want to, resolve host names, you could run that with the TAC-R. So before this demo, I did run it, and that's what this file is here, just so we don't have to sit and wait. And I don't want to, again, poke the bear if there's any actual malicious traffic in this pcap. So I have it on the side here. We can look at it later, but just going to run PacketSifter with the input file of demo.pcap. I'm going to run it with the AbuseIPDB integration and the VirusTotal integration. So when I hit enter, a lot of stuff happens real quick, but the main thing that happens is it's going to print out the metadata of the pcap itself. So this gives you information like how many packets are in the pcap, the packet size, the bit rate, all this sort of fun stuff, right? That you kind of just want to verify, right? We have hashes so we can verify that we're looking at what we expect to look at, all that fun stuff. But after that, it prints out a bunch of supplemental data about what's going on. So already we have an IO statistics.txt file that was printed out. This contains the protocol hierarchy that I mentioned before in the slides previously. And it also contains the input and output broken up in 30-second intervals. So this could be a way to detect something like beaconing, right? If I have a host that's communicating consistently every 30 seconds, this would be something you can use to spot that activity. It also prints out IP statistics and TCP statistics. So it has layer 3 information in one file, layer 4 information in one file, and also the individual conversations at layer 3 and layer 4 as well. A lot of good information in there. And now it is sifting through the HTTP data. So it'll print some metadata about the HTTP traffic in the pcap. And it also extracted all the HTTP objects and put them in a tarball. And it also, because I passed it that TAC-V argument, it went ahead and looked up the MD5s with VirusTotal. So now we should have an extra couple files in there of output that indicate that the VirusTotal integration was successful. And we'll take a look at that at the end of this here. Likewise, SMB, Similar activity with HTTP, extracts it, does lookups, all that sort of fun stuff. DNS, so it's going to create a new DNS pcap. It's going to extract the text records in the DNS traffic as well, just in case there might be any sort of, covert communications in text traffic. It also pulls out the A records, and because I passed it the TAC A argument, it is going to look up the IP addresses in the A record returns against AbuseIPDB. So we'll see, has there been any IP addresses that are known malicious IP addresses according to AbuseIPDB? What is the actual geolocation of these IP addresses? All sorts of that fun stuff there. This error comes out every once in a while. I think I have a situation with it's a dissector bug, so I have an issue with my TShark. Don't worry about that if that happens to you. It doesn't ruin anything. It's just a TShark issue more than anything else. And lastly, it will carve out FTP traffic if it exists. If it does not, it'll delete the ftp.pcap request that it made. So there won't be any extra files for you to look at. But that's it. So within a few minutes, and honestly, it's less than that. I was kind of just talking through it, right? But within a minute or so, it made the API calls and pulled back a bunch of data. And now let's clear the screen here and let's run ls. You see we have a whole bunch of files that came out of that. And so each one of these files as an analyst can aid you in the analysis of your Pcapp. And so for me, the first thing I want to look at is the input-output statistics, because this will give me an idea of the protocol hierarchy in the Pcapp. So let's go ahead and do a less against the IO statistics file here. And so I mentioned it'll carve out potential beaconing, so it has a 30-second interval. It shows you the frames and bytes in each interval. Again, not foolproof to find beaconing, but it can help you to see what was the biggest part of the conversation. Was there consistent bytes out or frames out, things of that nature. But if we scroll down to this, we get that protocol hierarchy statistics that I showed in the slide deck previously. And so this will highlight the various protocols embedded in the actual Pcapp itself. So if you don't know what you're looking at, this can give you a brief overview of, oh, hey, I have SMB traffic, I have LDAP traffic, I know I have web traffic, and there's media files in this traffic, and I have some TLS traffic as well, and also some art, right? So it just gives you a sort of brief overview of what you can expect to be looking at within this Pcapp itself. So that's one of my favorite ones that I go to initially in the beginning of my analysis portion of a Pcapp. So now that we have that, let's take a look at, for me, let's take a look at the HTTP traffic, because I like to see clear text traffic because that's the most exciting stuff for me, right? So I'm going to do a quick dive into the HTTP info portion. And all this does will give you sort of metadata aggregation highlights of various HTTP methods, response codes, all sorts of fun stuff. And when you go down to this bottom portion, it'll give you the requests by host. So it'll give you it pulls out the host header, and it'll tell you maybe what URIs were attached to that host. And so from here we see antivirus updat.y.com, which is a little suspicious, right? Because if it's antivirus update, seems to be a typo there. Could be some sort of typo squatting domain, right? We also see a naked IP address as one of the host headers in the web traffic, which more often than not, we're going to see web traffic DNS happens, we resolve a host name to find an IP address. We don't just really see raw IP addresses, in the host header itself in web traffic. So if I see that, then I know this might be some sort of hard-coded value, maybe in a piece of malware, for instance. So this is something we can look at and highlight here. And also, I see down here what looks like victorypunk-dc. So it looks like maybe a host name, maybe a domain controller, for instance. I also see desktop in here as well. And so this is beaconing out over 443 to another raw IP address rather than an actual host name like antivirusupdate.com. So within a few minutes of analyzing the output of PacketSifter, I was able to extract various indicators of compromise, like this IP address here, this IP address here, and potentially a typo squatted domain here. So all sorts of things that we can, analyze, write down, take notes, document, and look at later. So very quickly, we're able to discern that there is potentially something malicious going on, because I would ideally not see my host name beaconing out to a sort of random IP address, if you will. So that's interesting. And there's another case of that here. So very cool stuff that we're able to extract from this output file of PacketSifter. So in the sake of time, we're not going to dive into every single one of these, but the idea is that PacketSifter gives you a bunch of information, spits it out in a bunch of different files, and just lets you, at your leisure, at whatever cadence and sort of methodology you want to use, to extract information from this pcap. So I'm going to highlight the integration output that we use, the AbuseIPDB and the VirusTotal integration output. So real quickly, let's look at the Iplookup Results.txt file. So this is the output from the AbuseIPDB integration. And so what it does is it'll look up the IP address, show you the domain associated with it, print out the abuse confidence score. It'll also print out the country code and the country name. So I can look through here and see if does anything look familiar, or does anything look like I shouldn't be talking to it, right? If I'm a US organization, like I mentioned previously, and I see the country code RU in my pcap, maybe I should extract that IP address, write that down, and do further analysis on it. One little caveat to this is a crowdsourced abuse confidence score, meaning anybody and everybody can report anything they want. So just be careful when you're using this. If I see, a 100 score for something like a Microsoft Update IP address, which I've seen before, then you might, think, hey, this might not be that malicious. Maybe somebody just got it wrong. So just be careful. Again, I mentioned Microsoft.com here. I've seen these IP addresses referenced many times in high abuse scores, just because people don't really understand why endpoints are beaconing out to Microsoft.com. But it could just be, again, just because they want to just update and it's normal Microsoft traffic, right? So with that, I know in this pcap, if I want to look at really quickly, just see, do I have any high abuse confidence scores? What I can do is do a grep against that file, the Iplookup Results file, and see all the results back really quickly. And so I can get a quick look. Does anybody have a maybe higher than 50 abuse confidence score within that file? And I see a 16, I see a 5, but I don't see anything too high. So I didn't really get, for me, in my opinion, I don't see anything that's a quick win for me to look at and investigate. So I'm just gonna move on and let's look at the HTTP VT results. This is the output from the VirusTotal integration. So real quickly, just a brief overview of what the output looks like. This message file, and it's the hash, not found, means that the file is not found in VirusTotal. That means this file can either be custom malware designed for your organization itself, which is pretty scary, or it can just be a simple file that happens to not exist in VirusTotal's database, right? So doesn't mean good or bad. It sort of requires further analysis, but let me find one here. So one file that was found that it was undetected, meaning VirusTotal believes it is not malicious, is this hash here. So this is what the output looks like if you're going to find a file that does exist in VirusTotal. So in the sake of time, what I like to do is I just grep for the word malicious, similar to what I did with the AbuseIPDB output. I will just grep for the word malicious against that file and see, did any file come back malicious? And so I see, oh, there was this file here, it had a score of 47 as malicious. So now what I can do is just grab this. I know I have a score of 47 against this. And so let me grep for that against this file. So I'm going to grep for malicious against HTTP VT results. And I'm going to give it the tax capital C and 3 as an argument. So what this does is it'll print 3 lines before my grep match and 3 lines after my grep match. And so this will isolate the MD5 in question that was malicious potentially. So I can grab this and continuing on with grepping, I can grep against the HTTP hash to object.txt file, which is another output from that integration. And all this text file has is the MD5 hash and the coinciding name of the file that was found in the pcap. And that is what this looks like. So if I grep for this hash against this HTTP hash to object.txt file, I find that the red button.png associated with this MD5. So I can take this and, like any good analyst would do, go into VirusTotal. Let's plug this hash in there, and all of a sudden I have the actual output. And so I can do normal SOC analyst work, look through this, look at the community section of VirusTotal, see if I can find anything interesting. But I'm saying it looks like TrickBot is the malware that's listed here. So very easily, very quickly, I was able to find that this redbutton.png is a TrickBot executable. So one thing to highlight, right, is that this red button isn't redbutton.exe, it's redbutton.png. So it's trying to hide itself to appear to be a picture file. And so if I'm an analyst and I'm looking through Pcapp data, I might not have looked twice at that. If I just see redbutton.png from a GET request, you know, okay, whatever, it's downloading images. That's normal web traffic for a client. But because I use PacketSifter to do this, I was able to get the hash automatically done for me, that lookup automatically done for me, and I'm able to isolate that, hey, redbutton.png is in fact not a PNG. It is a binary of some sort that looks to be associated with TrickBot. So there's more to this. There's several different rabbit holes we can go down. We don't really have the time for that, unfortunately. And so that is how to use PacketSifter and TShark to enhance your Pcapp analysis. I'm a huge fan of TShark. If you have any questions about TShark or PacketSifter for that matter, any suggestions, please feel free to reach out to me. I'll also be on the Discord kind of while this is streaming so that I can answer any questions that might pop up. But if you think of anything after, please feel free to reach out. I love talking about this stuff. And that is it for me. CactusCon, thank you for having me. I really appreciate the opportunity, and I am looking forward to next year where I will ideally be there in person so I can enjoy the face-to-face component of this. So again, thank you for having me, and my name is Ross Burke, and have a good day.